Good morning, everyone, and thank you for attending AIA Miami's CEU in collaboration with PPM. As you can see on the screen, we're going to be going over as-built surveying best practices, field measuring, drafting, and modeling. And today we have, or be sure to send me your AIA member number, your email address, and your contact information to get credit for this CEU. That will be listed at the end of the presentation, but you can also do it at joel@ppmco.net. I'll put that in the chat so you have access to it, but if you can't email it to me, if you can't find it, feel free to send it in the chat and I'll record it later on. And I'll put my information in the chat as well so that you can do it at your leisure or after the meeting. And if you have any questions, please save them till the end. We'll have a Q&A section, and then for longer questions, we can also send them to the host and get back to you later on to have a more in-depth discussion. Now I'm going to hand it off to my lovely presenters. Go ahead, Alex.
Hi, everyone. My name is Alexandra Fong. I'm the PPM Regional Director for Miami. And with me today would be Greg. I'll let him introduce himself.
Hi, I'm Greg. I also work at PPM. I'm the Director of Special Operations, which is our way of saying national projects. And I've been working with PPM for about 8 years now, and with specific attention on 3D laser scanning technology and 3D modeling.
All right. I would like to start by saying thank you, Marilyn, and the entire AIA Miami for hosting us and allowing us to present this course today to everyone. We're very excited to be teaching our best practices as well as built surveying, drafting, and modeling methods. Without any delay, I'm just going to jump in and start exactly with a table of contents. Just to go back, like Joel said, you should email him your name, your email addresses, and whatever your AIA number so that you could get your hours for this particular course. Today we'll be going through 4 main sections, starting with the as-built plans. We'll go through the common definitions. What are as-built plans? How you gather information for your various as-built projects, and when your project will require a more detailed scope. We'll then touch a little bit more about the traditional surveying methods, starting with sketching, your plan views and your measurements, and also the Z-axis. Then we'll go into the laser and we'll expand a little bit more about the terrestrial laser scanners, the mobile scanners, the point cloud, and how you should be using your point clouds. And then we'll wrap it up with how we create as-built sets, how we're drafting from a traditional method, and also drafting from the point cloud. Throughout the presentation, we're going to have a series of polls in which I would ask you multiple choice questions. We'll also have a QA session at the end of the presentation. So if you can, please save all your questions till the end of this presentation. Now, I'm just going to dive into it, starting with what are as-built plans. Some common definitions as defined by AIA. An as-built plan is a drawing that is typically prepared by the contractor. There are more likely interpolations done for construction purposes, and they're done on the original construction drawings, and then the changes from the as-built are being done by the contractor in red ink. Therefore, the changes that the contractor makes onto this original construction documents and design sets are called the as-built drawings. Now, I'm very sure some of you have heard about record drawings. I don't want you to confuse as-built with record drawings. A record drawing is something that is a final drawing compiled by the architect, basically. These are drawings that mark up the notes on the on-site changes that the contractor makes on the as-built drawings. They are usually drawn and compiled as an architect-approved set of on-site changes made specifically per the owner's request. As you know, it's normally carried in the owner-architect's contract agreement. Record drawings are more reliable than the as-built drawings because they have been verified, they've been screened, and then approved by the architect. And last but not the least would be the measure drawings. Typically starts and it is introduced when you have an existing building that doesn't have any kind of reference drawings or any previously scanned anything that was recorded at a record drawing or an as-built. They're then prepared for the purpose of undertaking a renovation or documentation of an already existing building. They are derived for the measurements taken of a standing building, and these measurements are then created from an on-site project data. And just to sum this up, I know I talked about as-built, record, and measure drawings. One thing you just want to remember, if you forget everything else I've just described, is that your as-built drawing is being prepared by the contractor on site. The record drawing is then verified by the architect and entered, and this is much more, it's like a legal document, so it's much more accurate. And then the measure drawings are basically for fresh projects of already standing buildings. Next. We're going to go on to our very first poll. Just wanted to ask if any of you have used any as-built drawings being prepared, or you've had your contractor in the past prepared you as-built drawings as described in my previous slide. A would be never, B sometimes, and C always.
You can just indicate that in the chat. We don't
In the
have
chat.
a specific.
Yeah, in the chat. We'll just look at it later. Okay, I see a lot of more of sometimes coming in, and sometimes always. Well, a few nevers. That's quite accurate, I guess. All right, then I'll move into a little bit more about what as-built plans are, and keeping it more simple. I know this plan, as-built is a terminology that we've used a lot of times, and every time we do use it, I'm very sure we're all referencing a set of drawing that shows the existing dimensions and conditions of a building, space, or an area. Now, before we get any further, I would like to say that throughout this presentation, we'll be discussing producing an as-built plan in their final format, either as a 3D Revit model or a 2D CAD file. Both of these softwares are Autodesk, but I'm very sure there are many other drafting and modeling tools and softwares out there in the industry that you likely could use. So whatever we're going to discuss today for the purpose of as-built can be applied to any of the softwares that are available in the market. Now, the next question is, when do you need an as-built plan? Pretty much whenever you're working with an existing building. So when working with an existing building, you definitely need an as-built plan. And if you're working with an existing building and you're sure that maybe you have existing plans, but they're not reliable, you need an as-built plan. And if then there are no existing plans whatsoever, obviously you need some as-built plans to start your design. And then if you're working in a particular software, but probably already have this as-built plans from your client, but they're just not entered into the file format that you desire, then you do need an as-built plan to start your design. However, in all cases, you just want to make sure if your client does have an as-built plan, that it's the measurements are at least accurate. And if they're not, you could just have a quick measurement in the field to make sure that there are no discrepancies to determine if you need one or not. Now that we've talked about when you need one, what are the cases where you don't need an as-built plan? If your client already has the as-built plans and they're updated and already in AutoCAD format, then probably you don't need them. And if you're sure they're up to date, you don't need an as-built plan. But be very certain that this is the case, as I'm very sure most of the time when clients do reach out to you, they do not have this as-built plans or any updated plans that show the accurate depiction of their buildings. And then sometimes when you're working on a minor cosmetic renovation, you don't need an as-built plan for anything. And then if it's a new construction that you're starting with the construction documents, again, you don't need an as-built plan. Now, sorry, I might be going a little bit faster a little bit here, but I'll slow down a little bit. If you have any question, like I said, just put it in the chat and I would be sure to circle back on it later. So then when is the best time to then obtain your as-built plan? Pretty much before you start any design process, you want to make sure that you have the right plans with the right dimensions, right information. There are many cases when you'll be working with a historic review, and then they will require you to have an as-built plan created. You need an as-built plan at that point. And then most engineers will want a fresh and accurate set of as-built plans before starting any seismic retrofit project. And lastly, but not least, if you're working on a tear down project or remodeling or demolishing anything, you might need, the department or the city might require that you submit an as-built plan before you start doing any kind of demolishing work on your project. All right, and the other contributing factors, as mentioned on my previous slides, there are different municipalities that work differently and have different requirements. If you do require any as-built plans for any reason, the type and the scope that you need may vary from city to city. And if you plan to preserve or improve upon a detailed architectural element, such as an ornamentation, then you need to consider that documentation and where it would fit into your timeline. Overall, the size and the scope of your project would determine when an as-built plan is needed. And we would also discuss further in the next sessions when you would actually need those as-built plans and to what detail it's being required. All right, now that we've discovered maybe you need an as-built plan, we need to discover how much detail is needed and to what degree you want to gather and collect your information and what scope is needed. Okay, we do have different plan types depending on the project, and above we just have a few ones listed, such as your floor plans. Your floor plans are most always needed. If you're starting any building, you definitely obviously need your floor plan laid out for you. And then if you're working on the exterior elevation and you need some improvement work done on the exterior of the elevation, then you probably need an as-built plan, including your elevation plans. And then you might need so we do have sections if we need, or you're working on a height constraint or need to show the vertical relationships between your spaces, then you need an as-built plan that has a plan item, for the sections. And then we also do have the reflected ceilings that capture your lighting work and other MEP requirements and any kind of unique ceiling features that may be needed in the project. And now, before we get into any specifics regarding these plan items, I would like to go over some ways to gather the on-site information, starting with a very simple and quick method and then ending with a full-blown as-built plan. First being the photos only. One way to obtain the answers that you need when you visit a site before any renovation work is done is by simply taking photos. This will assist you in your design process and answer some quick questions that you might have before you start proceeding with your survey and your project. You can also, the single line is the next process and method, and sometimes you just need a single line or a very quick bubble diagram that shows you what you need to achieve as per your goals. And it can be very quickly done on site, and you don't need to have it really drawn to scale. And you can then sketch, and sketches are very helpful in supporting your design. In the cases of like an interior elevation or perspective, it can be done probably quickly, and you might not require any measurements. You just need the perspective of what you're perceiving visually. Then you might need to measure. If you need to have a full-blown scale drawing, then you need to probably measure, and such as when you need to create your construction document, you need to go to a higher level of accuracy. You need to probably measure the existing conditions, and how you're getting these measurements would also vary, as you would see in the next slide and in the next few slides in this presentation. So most remodel projects may require a very detailed scope of as-built plans. This will then give you a head start in the creation of your design, your submittals, and your construction documents. Now, to sum up just the first part of what we just discussed now, we basically understood now what as-built plans are by simple definitions. They're a simple defined set of plans of any structure that's existing at the moment. They're most often used for renovation or any kind of, construction that's needed. Getting an as-built plan drawn in the format which you work in is very important. So you need to verify, if you're doing an as-built plan, you need to verify very early on exactly what file format you want your plans in. Then the scope of the as-built plans and the detail of each scope item will vary depending on the need of the project and what is required by your local jurisdiction. Now, we're going to talk a little bit more about the traditional methods of surveying, starting with sketching, which is quite very near and dear to most of us, if not all of us at PPM. So a few things you want to keep in mind when you're sketching is to remember that the drawing does not need to be to full scale. All you need to do is make sure that there's room for you to write all your measurements and that it is very visually easy for you to read when you're back in your office and drafting it back in your softwares. You want to make sure you're using different colors to mark your different dimensions, and also, it makes it so much easier for read and also easy to keep track of what you're recording whilst you're on site. You also want to make sure that before you start taking any kind of measurements, that you do sketch your building completely as accurately as possible, so that when you do start taking these measurements, you can focus just on that. It's much faster, it's much easier, especially when you're taking running dimensions. The better your sketches, then the much more easy and faster it is for you to take down your dimensions. Make sure when you're sketching, especially on your site, you want to make sure you have a large sheet of paper that you're sketching on. Blow up your sketches as big as possible so that you do leave room for taking not just the dimensions, but also writing important notes that might be useful to you later when you start drafting. And also you want to plan ahead of time that you're going to take your height dimensions, which is the z-axis dimensions. Most of the time, this information can still be displayed in the plan view, but occasionally you might want to sketch it in a section or an elevation. We can talk about this process much later in the slide, but you want to make sure that if there's any particular detail that was not captured in your floor plan, or there's an annotation that's very important to you, and the precision and the degree of precision is very important, that you sketch it on the side of the paper as well for when you start taking your measurements. Last but not the least, you want to make sure that you take very good notes, because this will help you remember exactly the site conditions and what any other important information that you may need to draft it, if you're the one drafting, or if someone else is drafting, which typically might be the case, that you have as much as possible, so many notes that would guide the person drafting to know exactly what is needed and the precision that's needed on your as-built plans. Okay, now we're going to talk about sketching from your plan view and taking in your measurements. So when you start taking your measurements and you're sketching on site, one step that's mostly ignored by most people, but it's very important, is that you start with your exterior facades, your exterior faces. Because often, you already have the exterior thickness of your wall established, and you want to make sure that you start from that, and then you can take your interior dimensions from there. It's very crucial that you do this process and you follow through. A very quick and a very important tip is that while you're taking your dimensions, that your X and Y axis summation equals. So if you have your X access the dimensions for your, maybe the left side of the building, and you tally that up, you want to make sure that it's close enough, or if not exactly the same as it is on the right side of the building, same with the front and the back of the building. That way you're already putting in checks and balances to make sure that there's no room for errors, and that, you know, your dimensions are as accurate as possible. Obviously, this is very much easier if your building is completely at 90 degrees, but if it's not, then you might maybe maybe have some references here and there to see how you can get as accurately as possible. So now that you've taken all the exterior dimensions of your site, that's the perimeter of your building, we then move into the interior, just as shown in this sketch on the right side of the screen. You'll notice that overall measurements is, you do have overall measurements, and then you have small incremental measurements. It's a very good system of checks and balances that would not only improve the overall accuracy, but it will also save you time in the event that you do enter incorrect measurements or any kind of notations. You also want to not forget, again, like I said previously, take good photos, so that if you do miss anything on paper that you didn't capture on site, your photos would tell you, and then could flag maybe something that is a bit off that you didn't capture on site. You can maybe spot that immediately in a good photo. Yeah, so good dimensions from your exterior, then going to the interior, making sure you have your right dimensions, and then your photos to make sure that you do have a good point of reference in case you did miss something on site. Again, whilst you're taking all these dimensions, you might be working on a multiple level building. You might have various level of details that's required. It's always good to carry your tracing paper with you, your vellum. You want to make sure that whilst you've already sketched out your floor plan is as accurate as possible, but you need to take all the dimensions, you can easily lay over your tracing paper to take the dimensions as needed and keep your drawing as clean as possible for when you go back to the office to draft your plans. This is quite helpful, especially when you do have electrical plans. So you have your cabinetries and you have other smaller details that need to be captured on the plan view, but probably don't have enough room, sufficient room on the plan view to capture all those dimensions. So then we're going to dive into the Z-axis, which is obviously how you get in your building heights and your interior heights and elevations. There are various tools that we could use to capture our heights on the Z-axis. We do have the measuring tape, we have your laser, your distal, or the zip level. You can use your measure tape, especially when you're measuring like your riser plans, or you need to drop down from a balcony, or you just need to take a quick wall dimension. You can use your laser distal to perform your trigonometric functions instantly, and you can get all sorts of your heights combination that way. I'm very sure most of us have used the first two tools. Probably the last one is not as commonly used by most of us, but yeah, the zip level is an excellent tool that helps you, and it's an excellent tool that was invented and distributed to repaired if needed by a company out in San Diego. I'm not sure what version of this tool is, but you know, it is used to read heights anywhere above a 50-foot radius. So especially like a roof, at that point, you might need a zip level to take the dimensions when you're at the roof level. So you want to pay attention to your floor to floor heights, and also if you have any floor finishes that might affect your floor heights, you want to take that into consideration. However you collect and measure this height, just make sure that you've got them in the places that you need them, and that most of the areas will be obvious for you, but just be sure that you take them, and then take them at your staircases, take them at the steps, and anywhere else that you need to have your floor to your floor to floor height specified, or floor to ceiling in some cases. You also need to capture the heights of your ceiling, sorry, your roof ridge. You want to plan ahead to create your exterior elevations. You want to make sure you capture the right header heights. You want to make sure you capture your roof hangs, your eaves, and all of that dimension, which you need to make sure you take all of that on site, probably using the zip tool, like the zip level, like we discussed earlier. So you want to plan on what you need to see on your exterior elevations in your sections. Make sure that you have either some basic height and a good pitch information for your roof, or if it's safe, you want to actually get on that roof and gather as many height information as possible. Make sure you do not forget the heights of the openings of your windows in the areas that you might need to show it on the plan. You can quickly just scribble down on the plan view. You don't need to sketch a whole elevation for that. If you have a wall sconce on the elevations, you also want to make sure that you capture that. That's something, again, you can just make a quick note on the plan, unless you need to sketch an elevation to capture that height information. Now, to summarize what we just discussed about the traditional methods of surveying, overall, you want to make sure that you have a very good sketch. It's very important. What you need is a sketch that displays and contains all the measurements you need in a drafting. You need to encapsulate the structure by measuring around it. This will give you the skill when you begin drafting, and will ensure that the interior measurements are done correctly. Then after taking these measurements of major items like your walls, your doors, and the windows, you want to move to the next level of details as needed. This can be your cabinetry, your plumbing fixtures, or even the electrical and the ceiling components. And just to wrap up what we just discussed, take us to our second poll. I just wanted to ask how many of you are comfortable with sketching and measuring for your as-builts? A, being very comfortable. It makes me sweat just to think about it. B, being I've done it before, but I don't like it. C, being I'm comfortable doing this. And D, I always sketch and measure my as-builts. I love it. Oh, a lot of B's and C's. Interesting. All right, okay, that brings us to the end of the traditional method of surveying, and I would like to pass that on to Greg, who will talk a little bit more about the laser scanning method of surveying.
Thank you so much, Alex. I love seeing such a mix of responses to that last question.
Yeah.
So many people who break out in sweats, and then people who just love it. And I gotta say, I think this might be the most we've seen in any one of these CEUs that we've done, with a strong group of people who really love doing the traditional as-built surveying method, which is how I came up on it. This all brings me back to the good old days, and I miss it. I miss having that puzzle to solve in the field. But I'm looking forward to talking about laser scanners, or LiDAR, and point clouds to gather as-built survey data, since that's primarily how we're doing it now. So, in our case, we switched from this traditional method over to this laser scanning method, and updating or replacing a proven method for doing something to utilize the newest technology is never easy, no matter what industry you're in. The first step you take is the most important, and the rest is hard work and diligence. So even though it may be difficult to transition, making the change to laser scanning as a survey method provides you with everything you see here: fast acquisition of as-built data using the lasers, more accurate than any measurements that can be taken by hand, which reduces the odds of human error. It can be purchased, rented, or contracted as a service. It's a thorough solution that allows you to gather more data than needed to complete drawings for most projects. And it provides something that we call a digital twin, just a 3D picture of the property that allows us to sort of visit the site from the comfort of our office. instead of having to make multiple visits back to the field. So here are some examples of each type of laser scanner. There's two primary types, the terrestrial on the left-hand side and mobile on the right-hand side. Terrestrial is stationary, and the mobile means it can be moved while scanning. So the terrestrial scanner sits on a tripod, it spins to gather 3D information from one position, and after scanning hundreds of individual positions with really good overlap, you can bring all the data together into one big data set for your project. The mobile scanner on the right allows you to get a similar end result, but by utilizing an algorithm called SLAM, which stands for simultaneous localization and mapping. The scanner and accompanying software allow you to gather the 3D data while simply walking through a space. So this dramatically reduces the amount of time needed to capture the 3D data in the field. Light detection and ranging, that's what LiDAR stands for. LiDAR is a method for measuring distances by illuminating an object with a laser and measuring that laser beam's reflection with a sensor. So each one of these illuminations can be considered a single measurement. Each single measurement is logged, and throughout the course of the scan, millions of measurements are taken in all directions. So either way you choose to go, terrestrial or mobile, using this technology will result in creating a point cloud. Hi, Marilyn. We can hear you, by the way, Marilyn. You're unmuted, and I don't know if she can hear me. Anyway, so let's talk about some terrestrial scanners that we like to use in the field. Next slide, please. So this is the Faro Focus. It's a terrestrial scanner. Color resolution on it, which means that you can get a color point cloud, and you can also get panoramic images along with the point cloud. And it has approximately 1 millimeter precision in its measurements. That means any given measurement that it takes, plus or minus 1 millimeter in accuracy. And then the next slide. So this is the Leica RTC 360. That's, I guess they used a picture of me as a model here showing off the scanner. But this is also a stationary scanner. It's terrestrial. It's the scanner that we like to use in the field. It gathers more data in the field. It gathers 2 million points per second. And that just means that it requires less time in each position to gather the information for each scan. It just allows us to get the as-built surveying done more quickly. It also has kind of a 1 to 2 millimeter precision, which we have here marked as 1/16 of an inch. And even though this needs to be set up on a tripod, the individual scan times are relatively short compared to the other terrestrial scanners out there. Also comes with an iPad app that helps make sure that you can check your point clouds before leaving the site, which is really useful. It's extremely precise, even though some other terrestrial scanners offer even higher levels of precision in the resulting point clouds. Typically for what we do, we don't even really need accuracy that strong. Sometimes we do for ornamentation and MEP, but this has been a great fit for us. So in the next slide, we'll see a short video of a scan taken with this scanner. So as the video plays, you'll see that while our other scanners can be moved while they're operating, the RTC 360, by virtue of being placed in multiple positions all over the building to get a full set of measurements, it allows the scanner to gather very fine detail throughout the survey, creating an almost photorealistic and millimeter accurate 3D data set. We navigate through this point cloud by picking scan positions throughout the property to help us find specific details that need to be communicated, as well as confirm we have all the data we need to put together our final product. RTC 360, like I said, super fast scanner, capable of gathering 2 million points per second, and that's up to a range of 330 feet away. And you can really see all the detail that comes through in that video. It's not a photo. Each pixel on the screen represents a different measurement taken. So what you're seeing is actually a visual representation of measurements and not a photo. All right, so let's talk a little bit about the mobile scanners. So the terrestrial scanners make great looking data, but what we're most familiar with using at PPM are these mobile scanners. So this is the GeoSlam Zeb Revo. That's one of our best surveyors, Frank, out there in the field getting work done with it. So the trade-off for a less colorful point cloud or a hyper level of precision is that with a mobile scanner, you greatly reduce your time on site taking measurements because the scanning is done continuously while walking through a space and does not need to be mounted to the tripod. Even stacked up against the Leica scanner, which we just discussed being really fast, 3 hours of scanning with that Leica scanner on the tripod can be cut down to 15 minutes with a mobile scanner like this one. These scanners are also very modular. You can mount them to other equipment or mount other equipment to them, like a GoPro camera, but you can also even mount the scanner to a drone or to a robot. Another scanner that we like using is a mobile scanner from the same company that makes the RTC 360, the BLK to go. This is a newer model from Leica. Between this scanner and the RTC 360 that we mentioned previously, there are some pros and cons. For example, this produces a much more photorealistic point cloud, but the level of precision is a little bit less. That said, we find in combination using those two devices together allows us to do a wide variety of projects extremely quickly and extremely accurately. So in the next slide, let's take a look at a short video of a scan taken with the Zeb Revo, that first point cloud we took a look at, or that first mobile scanner. So you can, oh, yeah. Okay, there we go. So you can see that even though there is no photo-based colorization on the points in this villa, the points are colored on what is called a height ramp. That's where points at different heights are shown as different colors on a spectrum, which you can see on the left. Red is a lower height, blue is a higher height. Coloring the points this way makes it easier to see important features in the point cloud, even without a photo colorization. Okay, so mobile scanning and processing. What does this really look like in the field? So using a mobile scanner is preferable if your time on site is limited. Like we said, it can be as little as 10, 15 minutes on site to scan a building. Once the scan is complete, you want to use the SLAM algorithm software that comes with the scanner, and that'll interpret all of the measurement and movement data gathered by the scanner and produce a 3D point cloud like you see our surveyor Daniel looking at there on his computer while on site. Most individual scans take only 15 to 45 minutes. This will give you time to process the scan on site so you can check your point cloud results before you leave. That's really important just in case something goes wrong with the scanner or something wasn't gathered correctly. So as part of that, you want to make sure you review your complete point cloud on site. It just helps ensure accuracy. Most of the errors that you would see in scanning or processing can be spotted quickly, and actions can be taken to ensure the overall accuracy of your project when time comes to draft or model. Okay, so we've talked a lot about this resulting point cloud that comes from the laser scanners that I just showed you. But let's talk a little bit more about what a point cloud is and what to look out for before bringing it into your favorite CAD or BIM software. So reviewing your data well before attempting to create a set of as-built from a point cloud is a must. If there are any kinds of errors within your cloud, which do happen, then using that bad data can either stop you in your tracks later when you're drafting or modeling, or even worse, result in an incorrect set of as-builts. So once your scan has processed, you'll need to review the output. Did you cover all of the areas of the building? Do you notice any flaws or errors in that point cloud data? And specifically, we're looking for something called drifting. And okay, so here's a good example of drifting. You can see where the exterior portion of the exterior wall of this building has kind of drifted away from that nice square rectangular interior surface of that exterior wall. So if something like this occurs, you have some reprocessing options within the software, but also there are some best practices that need to be followed when using the mobile scanner, like completing a loop around the building when you're scanning. Sometimes just the ways in which you scan can help improve data like this. In this instance, the surveyor wasn't able to walk a full loop around the entire building to help the algorithm lock in the accurate perimeter. So determining the reason for the error is crucial to informing your decision on how to best reprocess or rescan your project. Now that said, here's some other examples of drifting. So in this case, the bathtub on the left is incorrectly showing itself to be in the kitchen area. The vanity on the right side isn't in line with where it should have been. You can see the arrows. It's creating that big dark gap there. So this is a clear example of there being a room that has drifted out of place with the rest of the point cloud in the project. Another example of drifting, in this case, this was an internal error with the scan. This was in the scanner. This was indicating to us that the scanner needed to be sent back for repair. So you can see some kind of heavy and rotational, looks like rotational drifting. Ultimately, our drafters are able to work with something like this. You can see that the lines are, for the walls and the windows are still pretty clear and visible, but it can be a little bit confusing and make the drafters work a little bit more difficult. So even small amounts of drift can make it difficult to place walls precisely. Duplicate lines are shown here, and it makes it near impossible to discern what is accurate versus what is a scanner error. So this is why our surveyors are always paying extremely close attention to their data on site to make sure that before they leave, they have the most accurate data. Now, some scanners are better than others at different types of projects, but all scanners run into some challenges in creating good point cloud data in certain field conditions. So when scanning attics, foundations, large sites, or multi-level structures, you may run into issues getting all your data to fit together with the mobile scanners. Areas that are hard to access or have lots of reflective surfaces or have fewer unique features. By fewer unique features, I mean scenarios like an office hallway that's just the two long walls with doors in exactly the same locations. Things like that can all pose a challenge to the SLAM algorithm when trying to produce good point cloud data from the mobile scanners, which is again why our surveyors do a really good job of making sure that they have everything they need before they leave the site. So most scanners have a range of hundreds of feet, which can produce a lot of data outside of your project that you don't need. So you may need to clip or crop your point cloud to reduce file size by getting rid of this unwanted data. If you have to produce multiple point clouds for a large or complex project, it will be important to get comfortable with your point cloud software that will allow you to merge or register your clouds to more easily manage your data. So much like the traditional method of sketching and measuring, properly scanning a structure takes lots of practice to do correctly and efficiently. Once you are practiced with scanning and know what to look for when errors may have occurred, you will have the most reliable version of data you can gather in the field. You can be confident that the as-built plans you create from this data will be fully accurate and ensure a smooth and safe renovation as it progresses. Okay, so you have a point cloud. You got a point cloud. You've got a successful point cloud. You know the data looks good, but now what? Now what do you do with it? So now that you've processed and reviewed the outcome of your point cloud data, you'll need to do one of the following two things. Well, do it all over again if you found a lot of errors in the point cloud. Your best bet is always to start with the best scan you can get. Otherwise, You're going to bring that point cloud back to your trusty workstation and dig in with your point cloud. So we'll dig a little deeper on this in chapter 4, but as a little preview, in order to produce items such as a floor plan, you'll need to create a slice of the point cloud at a desired height and use that view to start your as-built drawing or drafting or modeling work. In addition to cutting these slices, you'll want to be able to move and rotate the clouds to easily get any viewer perspective that you need on the property to perform your work. While there certainly is a learning curve, any CAD or BIM software that supports point clouds can do this for you easily. So we're going to get in creating the as-built set in our next section here, but I have some slides that display just how you can get acclimated with the point cloud with the photos you've taken on site. So here you can see a 360 photo on the left, which allows you to pan around within it in 360 degrees. And that's showing the same area that you see in plan view on the right in the point cloud. If it was safe enough to get up on the roof with the scanner, you're in luck, as you'll have some excellent data to work with in drafting or modeling, but it's still always good to have photos open while you do this regardless to ensure that it's correct. Scan data from inside an attic in particular can be very useful in displaying the behavior of a roof as well, in case you're not able to get on the roof to scan. Now, there's always opportunities for point cloud data to fool you as well. Here, it's not clear which way the door actually swings into the laundry room. So having a photo makes that super, super clear. So looking in section view throughout the project or even before you start your work is a good idea. You'll be seeing the structure in a way that you can't ever see it in person, unless of course you happen to have the biggest chainsaw ever made and permission to use it to cut the home in half. But we don't have that, and we rarely get permission no matter how nicely I ask. So having point cloud data is extremely beneficial over measuring with traditional methods when sections need to be created for the plan set as well. Okay, so to summarize what we just talked about, scanning your project will prevent costly revisits to site due to errors and will reduce your time spent on site because you'll have that digital twin to be able to review at any time. The type of scanner you use will be dictated by your needs and the level of detail required. And lastly, your scanner will create a cloud made up of millions of points, and knowing how to manipulate the point cloud in your preferred drafting or modeling software is crucial to using your survey data. And as an added note, while LiDAR has been around for about 20 years, more and more as-built surveys of all types are shifting away from traditional methods to utilizing the latest in laser technology. As with every new production method, there is a learning curve, but once mastered, the entire process gets much smoother. When incorporated with BIM technologies, the entire construction process can get a boost in speed, efficiency, and have lesser environmental impact. So that's it for me for now. Back to you, Alex, and then I'll see you all in a little bit.
All right, thanks, Greg. Thanks, that was quite insightful. Now we're gonna go back into creating an as-built plan set. We can now that we've already established that we've collected our measurements in the field, it's time for us to create an actual plan set. It's very important for us to keep these organized and concise, but at the same time, we want to leave room for notes so that we can take notes for whether it's the building information or whatever notes that you need to draft your as-built plans accurately. So then you can use them for your design layouts, your demo plans, and your construction documents, so on and so forth. All right, I know we've been talking a little bit more about the scanning with Greg, but I'll have to shift gear a little bit back into the traditional method and see how we can translate those sketches that we took into great as-built plans. So
Hey,
first,
Alex,
you want to make sure you
jump right
probably
in.
Sorry.
To interrupt you, I apologize, Alex. I'm looking at the time, it's 9:49. If we can, I do want to make sure we get a few questions in. So if we can keep this final section to about 5 minutes, we can open up for questions for about 5 minutes and make sure we're staying on time. Thank you, Alex.
No problem. So I'm gonna try and wrap this up real quickly. So you have your sketches, you want to put it right beside you on your computer and that's, drafting what you've already taken notes of on the side. You want to make sure that the file that you're drafting in is vector based, obviously, maybe AutoCAD or I've seen people draft from Illustrator before. You want to make sure that it's to full scale, entering all your actual measurements from your on-site survey. If you're modeling in Revit, it tends to be a little bit more difficult, but it's not impossible. Just remember that you're building rather than drawing. So often you would have to realize that your computer or your drafting software is going to control some of your measurements. Let them, because you've already set up your precisions anyway. So that would take most of your dimensions that you've taken. Like we did on site, we want to start exactly with the perimeter of the building. Your floor plan is going to be a comparison of single lines, probably with a combination of the blocks that you've already created. You're starting with your perimeter line, just like we did in the site field measurements. And then you want to move in to enter in your walls, then your windows and your doors. If you're working with multiple levels, you want to make sure that you're drafting your measurements, but also bearing in mind that your stairwells and your exterior facades align. This helps you keep your building aligned and also provide you a final means of checks and balance and making sure that you took the right measurements while you were on site. Next, then you want to, after you've entered all your doors, your windows, and your walls, which are mostly the controlling elements, you want to make sure that then you draft in your lesser degrees of precisions, like your cabinetries, your plumbing fixtures, your appliances. And if you're working on your electrical plans, which you've already sketched on site, then this is a good time to add your electrical plans and on your reflected ceiling plans. Obviously, it's going to be over your floor plan. Next, you want to make sure that while on site, we did sketch a lot of the behavior of our roofs. If you didn't do that, thankfully, thanks to Google, we have a lot of those aerial views that have been captured. So you could take your satellite photo and see exactly how your roof behaves. This means that all your hips, your valleys, your ridges, and the directions of your slopes, you've already measured all the overhangs and you get that into place as much as possible, be accurately as possible. On the same time, you want to make sure that you've collected the height information. You could achieve this by using the zip level that we mentioned earlier during the presentation. And you could also get on the roof and make sure you take the accurate readings. That being said, there are other methods of taking the right dimensions, like your angle finder, your level, and other various functions of your digital laser. So when you're drafting your elevations, when you're drafting, elevations will come directly from your floor plans and your roof plan sketches. The only exception is if you have special sketches that show certain aspects of your ornamentation on the exterior. Drafting elevations will entail placing the windows and the doors correctly on the front heights. And of course, it is important to ensure that they correspond directly with your floor plans in those cases. Any decorative items that you have sketched and measured can be drafted in as well. Drafting a roof plan in elevation view is one of the most difficult challenges as it needs to correspond perfectly well with the other elevation views. And then once you've located and you've cut your sections, once you've cut your locations for your sections, you will then use your floor plans and your ceiling informations that you've sketched to measure, that you've measured on site to complete your section view. To draft the roof properly in any section view, you want to make sure that your elevation view has been drafted correctly. This will help you achieve your section views a lot more precise and a lot faster. Hope I didn't rush that too fast, but that brings me to the end of drafting from your traditional survey. And now I'm going to kick it back to Greg so that he can continue about talking about how you can draft from the point cloud data you've collected on site.
Yeah, and we'll see what we can do to get through this quickly so we can get time for some questions at the end. Yep.
Yeah.
All right, so next slide, let's talk really briefly about level of development. Revit's just a very powerful tool. It can store a lot of information. So AIA and BIM Forum has put together what's called a level of development specifications to help best define how much you want to develop your model. So level 100 on the simplest end is just a single solid 3D mass, and level 500 on the most complex end is everything. It's a virtual version of the entire structure: nuts, bolts, bolt threads, bolt diameters, etc. So in modeling as-built plans, we're typically somewhere between LOD 200 and 300. It's the most practical level of development for a light and usable model. Next slide. Oh, sorry. I think I might have been a little off on the slides. All right, thanks, Joel. When drafting in a CAD, all right, thanks. When drafting in CAD from a point cloud, you want to ensure your cloud is positioned orthogonally, so rotated, so everything is at 90 degrees. Position your cloud on the Z-axis in CAD as well. Scanners will not pick up smaller items, especially if they're flush with walls or ceilings, so you'll need to use manual measurements that you take in the field to place those items. Next slide. This is where there's a huge advantage in having a complete point cloud for drafting. As with electrical and RCP components, sometimes it's beneficial to revert to traditional methods to sketch ornamental items you'd like to include in your drafting. And the Revit as-built model, which, forgive me, I jumped ahead. Next slide, Joel. That's where I was talking about the level of development for the Revit models. We were talking about drafting from point cloud in CAD first, but here's where we're talking about Revit and drafting from the point cloud there. So this is where that level of development I mentioned, the LOD 100 and the LOD 500 and everything in between comes in handy. But again, for as-built, for most as-builts, LOD 200 and 300 are the most practical levels. Next slide. So here's an example of LOD 200. For example, the electrical plan in Revit looks just like a 2D electrical plan in CAD. This is an LOD 200 electrical plan. In this version, you would not see electrical items in 3D in your model. In order to see the electrical items in 3D in the model, an LOD 300 plan is what would need to be performed. Next slide. So Revit has a lot of tools to build site plans and topography, and because you have that point cloud, you have all of that information from the scan. If you only plan to model as-built of a structure, you may want to limit your site work to the areas that surround or touch the structure only, if at all. And there's some simple masking tools and model line tools in Revit to help hide some unsightly Revit artifacts that you may not want to see in a clean elevation like the one on the previous slide. So modeling from a point cloud, similar to drafting in AutoCAD, the first thing you need to do is just make sure that you can get your point cloud in Revit. You'll need to make sure it's in a recap format to do that. Using the point cloud to guide modeling in 3D can be more complex than in 2D. However, the benefits of having all the elements of a building related to each other in that point cloud and in the Revit can be valuable to your design and planning process. Most importantly, and I'll just kind of jump to the end here, modeling an as-built in Revit may seem overwhelming at first, but a solid order of operations for creating a usable Revit model will go a long way. Next slide. So first, point cloud setup is important, just like in CAD. Rotate it in plan view so the walls are easy to place orthogonally. Set your finished floor of your point cloud to 0, 0 level in Revit. Then you can create all your other levels and move them to be in line with everything else. So as you attach floors and attach walls, things are snapping right into place where they need to be. Once you're done, start adjusting your view range and view depths in your plan views so you can add walls, doors, windows, and other items that might be attached to the walls throughout the point cloud. Lastly, as with AutoCAD, huge advantage to having a point cloud in modeling. Vertical information in the point cloud is super helpful. Drawing sections and adjusting section depth is crucial to viewing point clouds in elevation section views to adjust window heights, door heights, and create roofs. And again, practice patience. If you're using a point cloud, roofs can be really tough to model and get them accurately to match the point cloud at first. So just practice some patience when you take that on. So some notes on the BIM process and as-built plans. The as-built BIM model can be viewed in multiple phases, so you can easily switch between the as-built demo, proposed and alternate proposed phases. Moving from the design phase to the construction documents phase for project is far more efficient when you have Revit in place. Having an as-built BIM model can make it easier to understand a project that you haven't visited yourself, since you can cut sections, view interior spaces, and review all roof massing all in 3D. Some say Revit offers a more intuitive design experience and allows users to present 3D images at the planning stages to owner or planning departments throughout the way. And in summary, drafting from sketches into CAD is a pretty straightforward process. It takes time to become efficient, but you'll just be entering measurements into CAD straight from your sketch sheets. Modeling into Revit from sketches can be done, but you may find during modeling you'll need to ignore certain measurements in lieu of letting the powerful software build the model properly. It's highly recommended for Revit to have a point cloud for doing that. But drafting from a point cloud in both CAD and Revit means that you'll be importing the cloud itself directly into the software and essentially tracing or placing components right on top of the cloud to help you accurately create your set of plans. Alex, back to you, and then we can get to some
yeah,
questions.
so I guess we're back to the final poll, the questions for the audience, right? So how long has it taken? How long will it take for your team to measure and draft 1,500 square foot of a single family residence? Just out of curiosity, if that's for those of you that are actually doing your own as-built plans. Any entry? Not seeing anything. 2 hours, 3. Okay. Rania said 2 hours. Valeria said 3. Carla 4. Okay. Any more coming in? 2 hours. So let's see, an average of 3.
All right. That's where I remember being in my heyday. Yeah.
Yeah. Okay. How long does it take us, Greg?
Will, we don't do the sketch measurements anymore. We just do the point clouds, but typically it takes about, for a 1,500 square foot single family residence, it would take us about 15 minutes to measure it. And then it would take us about a day to get it drafted. Depending on the scope though, depends if you need just floor plans or elevations, et cetera. Obviously, the more scope you need, the longer it takes.
Yeah, so 15 minutes in comparison to about an average of 3 hours. It's a lot of time value there, depending on whoever is looking at it. Okay. Oh yeah, depending on the scope. Yeah. So thanks, Rainier. That's what I said, 15,000 square foot. Any more questions? We're down to the very end. If you have any questions, I'm sorry we had to rush through the last few slides there, but I hope you caught some things. If you need this presentation and information, I'm very sure you can download from AIA, and we do have a recording, and I can send you a link. Joel would be in touch with anybody that wants more of what we just presented and want more information. You can always call our office as well. Questions, anyone? Or should we jump to the juicy other part? So I see a question here. How much do we usually charge? Depending on scope. It depends on a lot of factors how we do charge. But if we're doing a 1,500 square foot of space for a single family residential, Greg, do you have an idea? The range?
Well, the question as I'm reading is the cost of the laser scanning on average, not necessarily the
whole package,
the full project. So,
okay.
The cost of laser scanning does depend on what exactly you need from the laser scan. For example, if you need the terrestrial laser scanner and you need that kind of level of detail, we typically have a day rate. Smaller projects can take about a day, but for example, one of our surveyors is out laser scanning a 400,000 square foot warehouse, and he's going to be out there for probably 5 to 6 days. So we typically, for that kind of scanning, have a day rate. Depending on the size of the project, the day rate can be anywhere from $1,500 to $2,500 a day. The larger the project, the lower the day rate, because we'll be out for longer. And then for the smaller projects that require the mobile laser scanning, again, that sort of depends on the shape and the size of the project, but typically it only takes a day. Not too familiar with what those day rates are for there, but I think that might be starting somewhere around 1,000.
I apologize, everyone, for that. My dog just went crazy because there was someone at the door. But yeah, while we were answering that, I did see Samantha ask that she wanted both. Samantha, for the second part of that, you would need to specify the scope of work. We need to know, I mean, if it's for 15,000 square foot of space, it's just floor plan only. There's so many other variables that, you know, come into play for us to give you an actual quote. But if you do go on our website, I think we do have a range for, I think it's a 12,000 square foot of space. I don't know, correct me if I'm wrong, Greg. But yeah, but I can always, I can respond to that personally to you later, Samantha. I think the next question.
We do typically like to just make sure that we're customizing pricing based on the exact needs and the exact property. So all of our proposals that we put together are typically pretty customized, because, you know, 5,000 square feet of wide open space and only 4 walls is very different from 5,000 square feet of a very complex structure.
Someone did ask if the final product is vectorized. The final product, meaning our final plans, they're in vector file format. So if you're doing a 2D or CAD, a 3D file, I believe those are all vectors. Unless you're talking about the point cloud itself.
Yeah, and the point cloud itself is not vectorized. That's just a raw set of 3D data measurements. We bring that into the software to then provide the vectorization on top of it. So if you just want the raw 3D data to model from, you know, you can you know, purchase a laser scanner, use a laser scanner, rent a laser scanner, or you can call us and we can laser scan it. But from there, we have a team of people in Utah who are extremely proficient at, you know, quickly doing the vectorization from that raw point cloud data.
Awesome. Rennie asked if we use drones for the scanning process. Depending, if we're so much high up there and we need a drone and the scope is so much large, it all depends. We do use drones. Most of the times we do use laser scanners. If you're doing like your single family residential, something that we can just use a ladder to get on the roof and go around the property. But we've used drones in the past.
Yeah, and the drones that we've used in the past are primarily just for taking photos of the property from overhead and from around. We don't physically attach laser scanners to drones to do that scanning, primarily because the scanning that we do doesn't really necessitate the full use of the drone. The laser scanners are pretty heavy. It takes a pretty big, beefy drone to get a laser scanner up in the air to do the actual scanning. And typically that's reserved for more agricultural processes and again, kind of like forestry cases. So that's when you need to really survey precisely a large swath of land using you know, laser scanners and either like fixed wing drone or just larger drones. So the times that we use drones, typically we're getting photos in instances where the satellite data isn't good enough. We can't get up on the roof with laser scanners, and we're using those photos to give us additional reference information that we wouldn't be able to get otherwise, because it's unsafe to access the roof. Yeah, there are some opportunities to use those photos to create point clouds through a process called photogrammetry. It's just not as accurate and precise as using the lasers, and typically still need some kind of laser scanning device to make sure that the photogrammetry data is accurate.
Perfect. Valeria said, thank you so much. It was quite informative. Thank you so much, Valeria. We're glad to provide you some value this afternoon. And if you have any more information or questions that you want to gather more information for, do not hesitate to reach out. You can call us or email us. I'll be right here for you. Richard asked if we do have architects on staff for PPM. Greg?
We have a lot of people on staff who went to architecture school who are
Yeah.
former architects. I don't believe we have any currently practicing and
I'm not
licensed
practicing.
architects.
I went to architecture school myself.
Exactly.
Practiced for a bit. I'm an architectural designer, going through my my licensing, but yeah, I'm right here too. So yes, we do in some aspects, I guess. Anyways, you get to see credit for this. There's an AI member just in case. Cool. Okay, thank you. Any more questions? Thanks for the presentation. Thank you guys. No problem, Richard, if you have any more questions. All right. I think that brings us to the end of it. I think Joel will probably wrap it up because we'll probably have a surprise for all those that attended today and our viewers. Joel?
Thank you so much, Alex and Greg, for that presentation. Even I learned a lot because I'm still fairly new to PPM. So now I feel I can go out there with a little scanner and do it myself. Thank you everyone in the chat for your great questions and for your continued patience with this presentation. As a surprise, like Alex mentioned, we actually have a raffle that we're going to be giving off to one lucky winner. You can see this sweet Lego set on the screen. So one attendee will be chosen at random and contacted later on for shipping information. And please, in general, don't forget to submit your AIA number and your other contact information so that you can get credit for this course. And that you can see at the bottom there, my email. I'll put it again in the chat just so you have really good access to it. But it's joel@ppmceo.net. I'll go ahead and do that now while I'm talking. Let's see. There you go. All right. And that is it. Thank you again so much, everyone, for joining. And thank you, Alex and Greg, for that great presentation.
Yeah, thanks, everyone. It was nice to meet you. And thanks, Marilyn, again, for helping coordinate this.
Thank you. Thanks, guys. Thanks for joining in. Bye-bye.
Anytime. Bye-bye.